This should have been a straightforward repair, but sometimes assumptions get in the way. So let's squash those assumptions and test everything ourselves. Hello and welcome back to Noel's RetroLab. Today on the workbench we have a Commodore VIC-20, and this is one of the ones that have been sitting on my shelf of computers to repair, so I know it's not working, but I have no idea what the problem is with it. So let's get started and see if we can save it from the landfill. So as usual, let's start by powering it on and see if we get any video signal first before we do anything else. And when we turn it on, we get nothing. Actually, we don't get nothing. We get a black screen, but the no signal message is gone. So that tells me the VIC chip is generating a probably correct video signal. It's just black. So it could be bad RAM, it could be lots of things, but it sounds to me like the clocks are working correctly and the VIC chip, maybe it's working correctly. So now let's open it up and let's investigate further. Clearly, I hadn't opened this one before because I always get rid of this as soon as I have to do anything with them. But everything seems very clean, seems fine. The lid of this is gone. Let's take it out all the way. All right, bye-bye. So this one comes with this capacitor on the back, and that's something that I've pretty much figured that this is normal. They came this way from the factory, along with a bunch of things in the video circuit that are different from the schematics. But yeah, everything seems to be in good condition. It's clean. I don't see any obvious problems. So, you know, I'm 99% sure the voltages are fine, otherwise we would not be seeing a video signal, but let's check that anyway. This video sponsor is PCBWay. More on that later when we use one of their PCBs. And so let's just check that the 5 volts are there. I'm going to check on the VIC chip itself, and that should be in pin 40. There we go, 50.01 or 50.1, perfect. Okay, so let's check a few signals just to make sure that everything is working as we expect and try to narrow down where the problem comes from. I'm going to start with the video out on the VIC chip, and specifically I'm going to look at the luminance signal because that also carries the sync, and that's very noticeable. And that's in pin 3, so right there, yep, and that's exactly what I would expect. Those little pulses, the sync is negative, so that's a sync, so each of those is a line, a scan line. And then the rest looks blank. There's no information there. That's why we're getting a black screen. I imagine chroma won't really tell us much of anything. Yeah, there's just nothing much in there. But at least we have the sync signal, which makes sense because that's what we saw on the TV. While we're here, I want to make sure that we are generating the clock out of the VIC that is sent to the CPU. So that's in pin 35. Be this one right here, and that looks good. Let's do the auto set so we can see the exact frequency. Yep, perfect, 1.1 megahertz. So that looks really good. So as a quick check, let's make sure that the CPU is actually getting that signal. So that's pin 37. It looks like it's getting it, great. And because a blank screen like that could be caused by the CPU not working, let's make sure that the reset line is low high, so it's not active. So that's pin 40. So this should be high. Perfect. Okay, so we don't have any weird reset stuck in there all the time, which could be causing that. So initially, just the first look at things, they look fine. They seem to be working. So given that everything is working okay, or at least it seems to be working okay, I think the next best thing to do is to try the diagnostics ROM in this cartridge. I'm not even going to bother with the rest of the harness. That just checks if some additional things are working. I just want to make sure that we have some video out with this and maybe it reports some memory errors. And if not, then something more fundamental will be faulty, either the VIC chip or even the CPU itself. So let's see what happens. So let's try it. And okay, we get black screen with some signal and nothing changes. So this looks exactly like we had before, just a pure black screen. So this tells me that it's probably not a RAM issue, although I'm not sure about the details of the VIC-20 diagnostics and how much RAM it needs, if any. I suppose it could be like the video RAM is not working correctly, but I'm leaning towards the CPU not being working correctly. So let's have a look at it and see if we can find something that doesn't seem quite right. Okay, I did a quick refresher on the 6502 with one of my favorite books, Rodney Sagg's Assembly Programming. And they have this very handy diagram, and it's not just a pinout, but it shows you which ones are input signals and which ones are output signals, which, okay, they're pretty obvious once you look at it. But the 6502 actually has surprisingly few output signals compared to something like a Z80. So I think the most important ones to look at are some of the clock outs and the read-write signal. That should give us a really good idea if it's alive or not. It may still not be functioning properly and generating those signals, but at least we'll get a much better idea. So in pin 3, we should be able to see an output clock signal, and that looks totally fine. And on pin 39, there should be another one I imagine is off by half a cycle. Yep. And the other major one, let's look at pin 34, which is read-write. And that looks like there's nothing there. Yeah, we definitely expect to see some activity there, unless there's something that is blocking the CPU, but that seems a little odd. That certainly shouldn't be that way. Okay, and what about some general activity? Do we see activity on the bus? So this could just be a very, very dead 6502 that is not generating read-write, especially read operations at all. I guess it's just barely alive generating clock signals. That's about it. Yeah, so unless there's something else holding it back from doing that, like a bad ROM, but we know it's not a ROM because we tried the diagnostics ROM itself. So I guess there still could be some hardware thing preventing it. Maybe it's locked in some interrupt or something. But at this point, I would lean towards replacing this one or even testing it in isolation. Is it getting any hot? Not really. It's a little hot, but that's probably normal. Should have done the temperature check earlier, just in case there was something really obvious, especially because this uses its own power supply as opposed to using a DC jack straight from the bench power supply. So I don't know what the current consumption is right now. That's usually a good tip-off. But I don't feel anything getting particularly hot. I'm not totally convinced that the problem is the CPU, but it seems something reasonable to try. It certainly fits with the symptoms we're seeing. Unfortunately, this is not socketed in this computer, but it's not too much of a problem with a good desoldering station. So let's pop it out and see if that was the problem. So let's try to find out if the 6502 chip was faulty, and for that I'm going to use the Backbit Chip Tester Pro, which I reviewed just a couple videos ago. And it's all set up for the 6502. This is one of the really cool things about this tester is that it's kind of specialized in Commodore components, and it has a large socket, and it does some testing, it's not super thorough testing, of larger chips like CPUs. So okay, we have it in place, and let's test it. Okay, so it seems it's passing. I'm assuming it's testing something more than just the clock signals, because we know those are working, but we were seeing no read-write signals. But this seems to imply that it's working. So just to check, let's put that CPU on this VIC-20, which I know is working. Unfortunately, I had the CPU socketed. And I mentioned this before, but it's usually much better to try a part that you're checking to see if it's faulty on a working board other than the other way around. If I took this CPU and I put it in the other board and we still got a black screen, we wouldn't know if it was something wrong with the CPU and something else, or if it was just something else. So this is a much better way to figure out, is the CPU working? So let's find out. And it looks like this one is working. So that was a false lead in a way. And the lack of read-write signal, it was probably due to what I mentioned. Maybe it was stuck in an interrupt of some kind, and some of the glue logic was failing and accidentally triggering that. So we need to keep investigating. I just realized that what I said earlier is not entirely true. The CPU is not totally halted. It actually has some activity, but only right after I turn on the board. So here, I'm gonna select read write, and I'm gonna turn on this, and there you go. We have some activity, and this one keeps going. That's the thing I'm finding. Every time I turn it on, it's slightly different. So yeah, I mean, now it looks like we have activity everywhere. Yeah. But I'm gonna do it again. And this is during the reset. And look at that. We had a little burst of activity and then nothing. So this is what we had the first time we looked at it. And yeah, if I look at the rest of the address bus or the data bus, we get nothing. So yeah, there's definitely some funky stuff going on in there. At this point, I was pretty puzzled. The VIC chip shouldn't affect anything, but I tested it just in case, and it was fine. And I even started checking the demultiplexers for the address lines, but I couldn't find anything obviously wrong. And the thing is, the VIC-20 is a pretty simple system. There just aren't that many things that can go wrong with it. So I decided to turn to an expert, and I asked Sven Petersen, the designer of many Commodore projects, including the VIC-20 test harness, and he mentioned that a bad kernel ROM could cause the symptoms I was seeing. I told him that that wasn't the case because I was testing it with the diagnostics cartridge in, so that would bypass the kernel ROM, right? Right? So to test that, I have a new kernel ROM here, not a new one, but the one from the other computer that was fortunately socketed. And since this one is also socketed, it's a very easy test. There we go. Let's see if that makes any difference. Okay, with the new ROM in place, let's check this out. Oh, that's what it was. Wow. Now, yes, we can pretty much ignore everything here because this is assuming it's connected to the rest of the harness, which I obviously don't have connected. I just wanted to use this because I thought this was going to be like the Commodore 64 and it was going to bypass completely the ROMs and the system. But yeah, that is not the case on the VIC-20. Let's find out exactly why. It all starts with the CPU, the 6502. When you turn on the VIC-20, the reset line is held low, active, for a second, and then it goes high. At that point, the CPU becomes active. The first thing it does is read a word stored in the address FFFC and start executing that code at that address. Let's trace things and see what happens. This is the memory map of the VIC-20. As you can see, the kernel ROM is mapped on the top 8 kilobytes of the 64 kilobyte addressing space. On the other hand, the memory for a cartridge is mapped at A000, so it's clearly not going there first. To try to find what's stored in FFFC, let's have a look at a hex dump of the ROM. The bytes at that address are 22FD. That corresponds to memory location FD22, which makes sense because that's also within the kernel ROM 8 kilobytes. So let's keep pulling on that thread. When we go to FD22, we see this code, which is correctly labeled as the power reset entry, so we're on the right track. It's relatively straightforward code, and the most important thing for us is that it calls a subroutine at FD3F, which looks for specific bytes to be present at address A004. Specifically the bytes 4130 C3 C2 CD, which is actually close to the beginning where the cartridge is mapped. If it finds exactly those bytes, then it finally jumps at the address stored at the beginning of the cartridge at A000. And just to double check everything, let's have a look at a normal game ROM like Raiden Fort Knox. And it seems to be exactly what we were expecting. That byte sequence starting on the 4th byte
and then the first 2 bytes are the address where the code actually starts. Neat. So yes, we most definitely need a working kernel ROM in order to be able to run any cartridge, including the diagnostics one.
Okay, let's plug in the rest of the diagnostics harness. And with everything connected now, let's give it a try. So it looks like everything is passing, but it's reporting bad user port. So that would be this expansion here, which, I mean, that's surprising. I guess I should clean it up a little bit, just in case that's the problem. Yeah, that's certainly pretty dirty. Okay, once more. Okay, it passed the user port problem, so that was definitely it. Clearly this doesn't have the best video output. For that, we probably need to do a similar mod to what we did a while ago, and it looks like now it's just repeating. So yeah, awesome. It looks like the only problem was the kernel ROM in this case. So to wrap this up, let's replace the kernel ROM with an EEPROM. In the past, I've made some homemade adapters, but those were fiddly and really never fun to make. Fortunately, there are several open source PCB designs out there to use 28-pin EEPROM for these kind of 24-pin ROMs, and I had several of those printed through PCBWay a while ago. This is a really useful thing to have in hand, and I would definitely recommend everybody dealing with VIC-20s and Commodore 64s to have several in hand. For some reason, ROMs fail fairly frequently in these computers. Anyway, let's go ahead and build it, which is pretty straightforward.
From the adapter GitHub page, we can click directly on Order from PCBWay. There you see a few views of the PCB, click on the Order button, and a few days later you get the PCB in the mail. It's really that easy.
Here's the adapter PCB, and really there isn't much to this at all. We're going to need some male pin headers to put underneath on the 24-pin connection, like so, and on the other side. And then we're going to need 2 sets of female pin headers, total of 28 pins, so 14 on each side, like this, so the ROM can go on top. One very important tip when assembling these kind of pin headers that are going to go in a socket is not to just put them here and solder them. If you do that, inevitably, they're going to be slightly at an angle and things are not going to fit correctly. So what I always recommend doing is getting a test breadboard like this and then insert it. And then that way you know that is at the right width. You can't really set them up so they're one further away. That would be too much of an angle. But if we solder it right now, this will be the perfect width and it will come totally straight. You'll see that in a second. And as a bonus, it also holds it in place. So it's really perfect for this. So now we can remove it and you see it's at a perfect angle. This will fit perfectly in the board socket. And finally, we want to short these 4 terminals right there. So I'm just going to add some flux. I'm going to pre-tin them. And now I put a resistor lead that I had left over. I usually save a few of these specifically for things like this. And that should be it. Okay, and after some cleaning, this is looking really good. And there's the adapter with the EEPROM already programmed with the kernel ROM for the PAL system. There's a couple different versions. There's an NTSC one, there's a PAL one. Those are easily available on the internet. Just download it and burn it. There's nothing special about it. It's 8K. And now we should be able to put this in the socket. and give it a try. And there it is. Beautiful. Clearly, the video quality can be improved a lot, but this is great. It looks like it's working. So yeah, I think we saved that one from the bin.
And one last little detail, let's print a label so that way we'll always know what chip this EEPROM is replacing. And there you go. I think that looks great.
So this VIC-20 is fully working and ready to go. One more rescued from going into the landfill. I know this wasn't a particularly challenging repair, but I personally enjoyed it quite a bit because it forced me to learn about the exact startup procedure for the VIC-20. And now it kind of makes me wonder how many computers I've dealt with in the past that actually require a working system ROM before they'll access a cartridge or some kind of external ROM. Anyway, I hope you enjoyed it. Leave me any comments below as usual, and I will see you next time.
If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.